Good morning, students. So welcome back to our Economics of Regulation class course. Last week I started with the introduction and giving an overview of and a refresher of perfect competition and monopoly. These are the benchmark structures we always look into once we discuss our industries, our network industries. And what I did then was starting and giving you an overview of the important concepts of technology and cost. I gave you this overview of the production function and how to derive from the production function the cost function and what that means then for profit maximizing behavior. What we also discussed were some concepts related both to the production function, economics or returns to scale, and in particular what is more important for economics of regulation and of network industries is the concept of economies of scale. And of course we also introduced the economies of scope. Actually that's what we are going to introduce today. I was too quick. What we introduced was the scale economy index, which is just average cost over marginal cost. So we have economies of scale if average costs are downward sloping and above marginal cost. And pretty much the last thing I did last Thursday, I think, was introducing the concept of subadditivity. And that's where I'm going to jump to right now if I find the respective slide. Yes, that's where we are now. I introduced subadditivity. Subadditivity simply is that the cost if I produce total industry output in one company is smaller than if I produce this in number or several, that is at least two or more companies. That's what we have, and that's actually our technical definition of what is called a natural monopoly. Simply meaning that industry output Q can be supplied cheaper, that is at lower cost, by one firm than by two or more firms. This is a technological definition, and from that it does not immediately follow, or in no case immediately follow, that we will actually have a market structure with only a single firm active. We will discuss that in much more detail later on once we get into contestable markets and so on. Okay, that's what we have. I also gave you this smaller side that subadditivity not necessarily implies falling or decreasing average costs. That's what you saw here, even though you might go up with the cost after some level. Still, it's cheaper to have only a single firm providing the whole industry output X1 here, rather than two or more, which would then have, if that's just X1 over 2, if that's then just half the output. And remember our tutorial class on Tuesday, where it was very important what the relevant ranges for whether economies of scale are still active. And because what we saw is if that was the example with the capital K, with the fixed capital, if for instance the demand curve would go through here, we would see over the whole range economies of scale. If the demand curve were out here, we would have several firms in the market and no more subadditivity. So that's what's important with respect to the relevant range. Okay, but now we move on to multi-product firms. Multi-product firms, what we already discussed on Tuesday in the tutorial class, was a multi-plant firm, which sets up several plants because each plant has a specific capital input. And of course, if it's rather small, you rather set up several plants. But now we move on to multi-product firms. In today's modern industries and economies, many firms make multiple products, and I gave you just a few examples here. My examples in the remainder of this part will basically be ones where I use different models of Volkswagen. You see Volkswagen produces dozens of models and has, I don't know how you call that, 3 or 4 brands. So they have Skoda, they have Audi, they have Seat, and they have the Volkswagen brand themselves, and they have subcompact cars like the Up, the Polo, the compact cars like the Golf, sedans, like, oh, I don't know what the Passat is, more like I think a hatchback, or how they ever call this. They have the Touran, they have the SUVs like the Touareg. So they produce multiple products, many different products. Same 3M is an American company producing very many different products. All of you will know the Post-its, okay? But they also certainly produce face masks and so on. Deutsche Bahn and Deutsche Telekom, that's interesting from our viewpoint of economics of network industries. Deutsche Bahn provides both train services, passenger train services, local train services for passengers, far distance train services for passengers. They provide freight services, and they provide the network infrastructure services from Deutsche Bahn Netz. Deutsche Telekom also provides you with broadband internet services, with mobile telephony services, with fixed line telephony services, and so on. So you see, today many firms are multi-product firms, and now we immediately run into trouble once we look into costs. What is a cost of a car, or what is a car at all, which Volkswagen produces? How do you define average costs for these firms? What is the average cost of a car produced by Volkswagen? And that's what we are going to look into right now, and look into economies, or first of all look into economies of scale for multi-product firms. So what is rather straightforward is to provide, or to somehow estimate or measure the total cost for a two-product firm. So produce, as I told you, I myself drive a Volkswagen Touran, so I will just give as an example the Touran and the Polo. So here you have these two products here which you produce. The marginal cost for product 1 should be rather clear. So what does it Volkswagen cost to produce one additional Touran car or one additional Polo? Okay. The problem is that you cannot say what are the average cost of cars, because the cars Volkswagen produces are made up of both Tourans and which is a larger car with probably higher production cost than the smaller car like the Polo or the Up. Okay, so what is the average cost of a car? And therefore, in order to define that, we introduced the concept of Ray average cost. This is a more restricted definition, and you will immediately see what this means. Okay, Ray average cost assumes that a firm makes two products, the Touran and the Polo, in a given quantity, in a given ratio. Okay, so suppose all of the cars Volkswagen makes, they are made up of two parts Polos and 1 part Touran. So yeah, actually, I should have used the Golf and the Touareg. Hopefully, all of you know these cars. So you have a car which is produced at a high percentage and a car which is produced at a low percentage. So the average cost of a car, of course, would change if you increase the production of Touareg, leaving the production of Golfs constant. Okay, so the problem is here, in order to get a measure of these average costs and economies of scale, you need to keep this ratio constant. And so if you keep the constant, then you can, of course, you know, if you produce 3 million car and one third is Touaregs and 2/3 is Golfs, then you know you will produce 2 million Golf and 1 million Touareg. If you produce 6 million, just use this for simplicity, you will have 4 million Golfs and 2 million Touaregs. And then, so more generally, you could just use some ratio lambda 1 and lambda 2, where lambda 1 plus lambda 2, the sum is simply 1. So lambda 1 would here be 2/3, and lambda 2 would be 1/3. And of course, implicitly, then the output is defined here. You know immediately, if you know the lambda 1 of the Golf and you know the total number of cars, you know how many Golfs are produced. Okay, and the Ray average costs are then just the total cost taking into account that if you produce 6 million cars, 2 million of the 4 million of the cars will be Golfs, and 2 million of the cars, namely 1/3, will be Touaregs, divided by the total number of the car. And now if you know exactly what these average cost of a car are, if you say have 9 million, because then you know average cost per car for if you produce 9 million car or something, like say 30,000 euro, and you know of these 9 million, 2/3 are Golfs and 1/3 are Touaregs. Okay, so that's just hopefully you got this point. You have to keep this ratio constant. Otherwise, if you don't keep it constant, of course, the cost per car will change simply because you change the composition. Of course, if the share of Touaregs goes up in your composition, the cost per car then would change. Okay, that's why it's so important to keep these ratios fixed. And if you have this, you can also produce or derive a scale economy index for the case of multi-product firms. Okay, for multiple products. Here's just I repeated or gave you again the definition of the scale economy index, simply average cost over marginal cost. Here we put it slightly different. As you will see, that's what we are going to use here. So for the multi-product firm, taking this second definition here, in a numerator you simply have the total cost, and in a denominator, what do you have here? You have marginal cost weighted by the output for each product. Okay, so this is simply a weighted measure of marginal cost. Each marginal cost for say product 1 weighted by the output of product 1. This becomes even clearer in the next step, where we just derive both. Actually, that's what we do here. In order to make this more confusing here, probably here I just divide both the numerator and the denominator by Q. Of course, this is just an expansion which is valid here, and what you get then is Q1. What you get then here is Q1 over Q here, and here in the numerator, you cannot see in the numerator you get the Q, and that's what you have then here again. Okay, and Q1 over Q, this expression down here, is nothing else than our lambda 1. Okay, yeah, and I now erase it again, otherwise you will be too confused here. Okay, but you see how we come up, and now you see also why this is a weighted sum of marginal cost. Okay, and the weights are the production shares. So you know 1/3 is Touareg, so the marginal cost of Touareg gets a 1/3 as a weight, and the Golf is 2/3, so it gets 2/3 as a marginal cost. And in a numerator, what we have here is Ray average cost. Okay, because here we determine each output of each single product as a function of the total output. Again, so you know if we produce 9 million cars, 2/3 will be Golfs, and so on. Okay, but this is completely analog to the single product case, and of course that's what I stress frequently. We keep the proportions, we keep the output proportions fixed, and we now can simply derive the Ray average cost. Okay, that's what we have. The Ray average cost enter here in the numerator. Okay, and now we can, here what we now have here is we can, and that's what you will do, we can just simply calculate the Ray, whether there are economies of scale. Okay, because we know if Volkswagen doubles its car production, we will see how that changes. Okay, that's what you will do in an example where you in a problem in a tutorial class where you just can simply calculate that. Okay, I don't know here later on I will get example once we look into economies of scope, but hopefully this should be clear. The only point you have to do is you just increase here, or in order to have the S, you just calculate it, of course, but in order to have some analog to the average cost curve, the decreasing one, you might just increase the Q. Hopefully that is clear with respect to ray average cost and now and how we derive the S, the scale economy index in this case, because we now turn to a second way to define multi-product economies of scale, namely incremental cost or average incremental cost. So the point is, in certain instances, it might not be appropriate to look into proportional changes in output. Actually, or for instance, in the notes I gave an example of Volkswagen again. The question is, if you have a convertible like the EOS, or if you have is that a multivan like the Charan, and you don't produce a lot of them, and you know you have some product development cost, of course, it's interesting to you to also have an idea of the average cost and how it evolves over the output range for these single product, for the single model of which you produce. And because this gives you an idea, or should give you an idea, how much you should produce, or how much you need to produce of that car, given a certain willingness to pay of consumers, so that you reach the break even. Okay, just perhaps I get back to this example later on, but just let me define what incremental costs are. The incremental costs of producing product 1 given product 2. So again, the incremental cost of producing a Touareg if you produce already a Golf. And what are the incremental costs? These are the total cost if you produce both the Touareg and the Golf, minus the cost if you produce only the Golf, that is nothing of the Touareg. So this gives you the incremental, the additional cost, and this is defined like this here. I see as a function of Q1 for a given value of Q2. So this is the incremental cost. What are the additional costs if you, first of all, don't produce nothing of a certain product and then a certain amount? And of course here, if you produce nothing, that's the 0 here. If you produce nothing, of course you don't have any product development cost. That's the assumption here. Okay, and average incremental cost would then be just the whole thing divided by the respective output Q1. Okay, for our Touaregs. And if AIC, the average incremental cost, is declining in Q1, okay, is declining in Q1, where are single product economies of scale in a multi-product context? And that's actually what's written in this article by Der Spiegel, which I have here in the notes. I think it says that the EOS only sold, I don't know, the EOS sold only 8,000 units, and that was in 2013, and the Charan 40,000. And now, of course, it's really clear that the AIC, given that you have product development cost and some other fixed cost specifically for the Charan or for the EOS here, the point is that you will have really decreasing average incremental cost here, and obviously it was not enough here enough demand given the average cost or the cost you have here, so that these were really profitable car models. Okay, so, and at that time, the point is what this article also states that for these numbers for these quantities, it just doesn't pay to pay the development cost for a new car, which are at a magnitude of several hundred million euros. Okay. Yeah. We will get back to this discussion of incremental cost and average incremental cost, because the concept of incremental cost is very important in European regulatory practice. In particular, what is called LRIC, long-run incremental cost, is a cost concept heavily used by the European Commission and all of the member states in the regulation of telecoms. Okay, then in German it's KEL, kosteneffiziente Leistungserstellung, which is slightly differently defined, but we will discuss that in more detail in a tutorial class, because we will have, actually I could show it even to you, we will have the assignment, if I find it, of course, yes, here it is. We have assignment 2, where I ask you to, if I get it here, you should now see assignment 2, and here you have, you should look up what LRIC is, long-run incremental cost, and there is something which is called LRIC plus. You will notice that, and KEL is only relevant for German-speaking students, but you should nevertheless get an idea of these concepts which are used in European regulatory practice. Okay, getting back to our discussion of economies of scale. Actually, this was a discussion of economies of scale. Now we move on to economies of scope, which is somehow the more interesting concept once we define or once we discuss multi-product firms. So, what are economies of scope? Economies of scope exist if it is less costly to produce a set of products in one firm than in 2 or more firms. The formal definition here for the 2 goods case makes use of what is called the standalone cost, which I briefly introduced already on the previous slide. The standalone cost of producing the Golf is just, if I produce nothing else, C output of Golf, CQ1, and the other output is 0. The standalone cost for, say, the Touareg would be then C, I produce no Golf, so it's 0, and I produce only the quantity of the Touareg. Okay? And economies of scope exist if the sum of the standalone cost, so here output standalone cost of producing the Golf, standalone cost of producing the Touareg, is smaller than if I produce all that in a single company. Okay? If that's greater than 0, we speak of economies of scope. Hopefully this is somehow clear. Of course, yeah, we will get back to that. If you look at a company like Volkswagen, which is amazing in the sense that it has so many brands, this would also mean do economies of scope exist in a sense that if this is Audi, if product 1 is Audi in a sense, product 2 is Porsche, product 3 is Seat, does it make sense to have it all in a single company, or are the costs higher than, so are the costs lower if I have it in a single company, if compared to if I have separate companies, okay? We would have economies of scope if the costs of having all these different brands and different models in one company, or if we would have global costs for global economies of scope for Volkswagen, if these costs are lower if they all are in one company. Okay, now we can also define such a scope economy index, which is actually the same as what we had previously here in a numerator, just divided by the cost. So it's not so interesting to derive this scope economy index because the critical value here is 0. whether it's larger than 0 or smaller than 0, and you see already from this term up here, you already get the respective sign of this index. Okay, no economies of scope if this is smaller than 0, economies of scope if it's larger than 0. That's interesting to look at something like our industry history through this lens. Perhaps some of you remember a firm called Daimler Chrysler, where I think Schrempp was the CEO at that time of Daimler-Benz acquired Chrysler, and obviously it turned out that it was not a good deal because it split up again later on. Okay, so it's not so straightforward to determine whether there are really economies of scope, because as you will see, you might also have a trouble to have too many to manage too many different brands within your or products within your portfolio. But now we will move on to look into what are the sources. Actually, slide ahead. We will look into the sources a little bit later. First of all, we define define another cost concept, namely the common cost, Gemeinkosten in German. This is then what you really can also define formally here. What are the common costs? The common costs are just total cost minus the incremental cost of product 1 minus the incremental cost of product 2. And now what I did in the next line is just substituting the definitions of these common costs here. Okay, here you see this is the incremental cost of product 1, and this here is the incremental cost of product 2. And if you simplify that, you see that this is thrown out, and so you get plus C0 Q1 plus C Q2, and I have to erase it again here, so otherwise you don't see it. And what you see here, the common costs are simply the sum of the standalone costs minus the total cost, or minus the cost if you produce this in one company. Okay, these are the common costs. The point is, and I think this is what we explain here. The common costs are the costs that cannot be allocated unambiguously to the production of a certain product or service. Just think of cars. Typically, all these cars have the same engine in it. So you commonly produce, you develop one engine for, say, 10 different models of car. This is then some like a public input, or actually this is more like a shared input. Well, it's a good discussion whether it's more like a public input. So the point is, here with the engine, it actually would be a public input. You produce this engine, or put it differently, you develop this engine once, and then you can use it in all. So the concept, the kind of the engine, of course, you have to produce it all of the time, but you can produce the blueprint. You can use the blueprint for all different cars. Okay, once you develop this engine for one car, it's costly available for the use in all others. Okay, and so if you have then standalone production, you have to develop an engine both for your Touran and for Touareg. Touareg probably has not the same engine as the Golf, but the Touran certainly has. So you can use the same engine in your Touareg, in your Touran, in your Touran and in your Golf and in your Passat and so on. So if you produced it once, if you developed it once, you can use this blueprint then for all others. And this is a public input, and this is what you save. Okay, and we will also discuss shared inputs, and I think I just move on to the next slide because I explain it in more detail there. So this is slightly different from a public input, this shared input. these are inputs which are used in the production of several products and usually result from indivisibilities and lumpiness. I will move on here. You see that here because I explain it in more detail here. Same equipment for various products is shared inputs. So if you have once a railway track from Gießen to the Vogelsberg, you cannot only use it for passenger train services, you can also use it for freight services. Okay, if you have produced and shared, here I have some examples. I think shared advertising, creating a brand name. If you have created your brand name Apple and you bring out a new product, you can already use this brand name. Okay, and marketing and R&D expenditures that are generic. So here on expenditure, this is actually what we already have. So if you see a Daimler advertisement on TV, they often don't show you the exact car. They just give you some nice landscape, and then they give you the Mercedes star and so on. And of course, that then makes marketing or advertises all of the Daimler cars and maybe even the trucks. R&D expenditures. So if if you if you invest something in R&D in terms of, say, new batteries, you might then use these new batteries not only in your cars but also in your trucks and so on, in several other respects. So these would be shared inputs. Cost complementarities are more related in a sense to our public inputs we just have. Okay. So producing one good reduces the cost of producing another, oil and natural gas, for instance. So if you see these oil wells, or if you actually in former times you could fly across or over the Arabian Peninsula, and what you see there is that they burn all the natural gas which comes out of the ground once they dig for oil. Okay. So here you see you typically get oil and natural gas together, and if natural gas is sufficiently expensive and if you care for CO2 emissions, you probably wouldn't burn just the natural gas but try to somehow use it and capture it and then sell it. Okay, so this is from production. This is more little like a cost complementarity, but the interesting thing is here, that's why I use this illustration. Crude oil. Crude oil is really an interesting public input. This is now the English version. Here I have the German one as well. Crude oil would be Rohöl, and you produce many different things which have whatever these temperatures are. In German it's Schmelzpunkt. It's not a boiling point. I don't know what is in English, but from crude oil you get out all these kind of different things. A gas would be then like flüssiggas, propane and butane, and you get here gasoline, you get diesel oil, you get these heavy oils and so on. You get asphalt, you get everything from the single output. Okay, the point is you put that in and you get the other things automatically. You would have to throw them away. Okay, so oil and benzene and so on. This is a bit like the cow. Okay, if you have a cow, it produces both the milk and the meat and even the leather from the hides. Okay, this is also a famous example, the cow of Economies of Scope, which is scope which is even used in a book by Baumol, Panzer and Willi. The final thing which I want to mention here is computer software and computer support. Actually, I'm not so convinced about that, because that would mean that people who write the computer software are also good at providing support. If you look at SAP, they always hire guys like you, like business administration and economics students, to explain to their potential users and customers their software, because typically I guess that the nerds writing software packages, or I don't know whether they are able to communicate at all, but certainly they typically have a hard time explaining how the software works for consumers. Retail, yeah, I leave that here for the minute. Okay, so that was already tour de force, rather quick. I think I just make a very short break here before I move on and discuss what that means in terms of subadditivity, and just ask in WebEx whether everything is clear. Okay, it seems that there are no important questions right now. Hopefully you understood all that. Probably the real advantage of providing that on YouTube is that you just can move back later on and watch it again. Okay, multi-product firms and subadditivity. So here we in the context of economies of scale, we introduce subadditivity in order to look for our natural monopoly. Is it cheaper to produce a single product within, or the total output of a single product within a single firm or in several? Now the question is, under what conditions do we obtain subadditivity in a multi-product firm? So should we produce all car in a single car company? That's more or less like what we had in a former Eastern communist bloc, where you had huge conglomerates which were the only ones to providing a certain services. Okay, and now here are to be just looking for the technical definition, of course, because it means that the subadditivity technically does not mean that it's optimal or that it's going to happen that we have a single firm being active, as I explained to you in some detail when discussing economies of scale. But now we want to discuss this topic of subadditivity in the context of multi-product firms. And of course, then we have to look into how economies of scale and how economies of scope interact. And now the point is, subadditivity of the cost function and therefore natural monopoly requires that we have both economies of scale and economies of scope. You might also put that more different or difficult as EoScope did it here. It requires both a form of multi-product cost complementarity and a form of multi-product economies of scale over at least some range of the output. So here, some form, you learned about two forms. So you learned about the array average cost, and you learned about the average incremental cost. So we need one of these, or maybe there are some other definitions, and we need economies of scope. Okay, and that's what we are going to discuss here. And actually, I could jump back again to say our problem set, our assignment. You will see, I think, you will have to discuss something like this here in the assignment anyway. Okay, so these are just examples. So the most easy or the easiest example you might come up with economies of scope is just the following, and I put it here. If you have C is equal to sum F plus Q1 plus Q2. So this would just mean you have some fixed product development costs. Suppose these are cars. You have some product development costs which are common costs for your say Golf and Touareg, and then you simply have such a linear cost function. And of course, this would be economies of scope, because it's cheaper to produce, because the F is really a common cost here. You would have it twice if you produce both standalone. And it also has economies of scale, because of course, due to this F again, if you increase, for instance, array average cost, if you increase the output, if you keep that constant, the ratio, you could do that just by doubling Q1 and Q2. You would see that divided by Q, this part stays constant, and the parts with respect to the Q's and the F over Q get smaller. Okay, that's the easiest example. We will have more examples here. Here we have in particular, I think this is slightly too small font here even for the slide here. But what you see here, this is really a strange example. Here you would have economies of scale because you have the 1/3 up here. But of course it would be stupid to produce the two products in the same produce the same product in the two products in the same company, because this adds some penalty here. If you produce this, it adds a penalty here and adds some cost. If you would produce it standalone, you would just have C is equal to Q, C1 is equal to Q1 and C2 is equal to Q2. Actually, perhaps this was what happened in the Daimler. You might really think that this is really strange, but perhaps this is what happened in the Daimler Chrysler case. Okay, you added another company. They both were working more or less well, but the point is you got so many troubles on the management board that this added so many frictions that the cost just increased. Okay, that's what we have here. So you have economies of scale, but no economies of scope, and therefore it's better to produce these separately. Here, the second example here, this one, the second with the global subadditivity. I think, I could just check here. As you see here, this is, I think, almost the same thing. And what I ask you in the tutorial class is to look up economies of scale and economies of scope for this function. So you will be able to check whether you understood this concept, and if there are problems, we will just move on discussing that in detail here. Okay, on next Tuesday in the tutorial class. Okay, it's actually the same, so I shouldn't discuss it too much, otherwise you don't have anything to do. Okay, so now the point is, first of all, you should be able to determine if you get such a cost function, whether there are economies of scale and whether there are economies of scope. The next question then, of course, is under what circumstance do we get global subadditivity, meaning that we really should produce all these products where we have some economies of scope in a single company from a technical point of view. Okay, always only from a technical point of view would production costs be lower if we produce it in a single company. And this is rather complex. That's again what Josco states. I gave you a quote in the notes: the necessary and sufficient conditions for global subadditivity of a multi-product cost function are complex, and it is not particularly useful to go into those details here. Okay, if we were in the 80s, we would spend hours and hours discussing trans-rate convexity. In the 80s, I mean the 1980s. Okay, so when I did my studies, we would have discussed these conditions at some length, but it turned out that you do not learn so much from that. The important point is that some economies of scope is a necessary condition for a multi-product cost function to be subadditive. Okay, so if there are no economies of scope, it doesn't make sense, or if there are even these economies of scope, it doesn't make sense to produce all of the different products in one company. And now, hopefully, you know the distinction between necessary and sufficient condition here. If you have sufficient conditions, you know that these conditions are sufficient. They are enough to guarantee that you have a multi-product cost function, but there might also be other not so strong assumptions which give you the same result. This would be the necessary ones. Okay, so the point is that, and I don't go into detail here, you have some economies of scope and some declining average incremental cost. That's sufficient. trans rate convexity. I don't want to discuss that. Go to Beaumont's book if you want to spend more time of that. Some cost complementarity. Cost complementarity here meant as a property that increased production of any output reduces marginal costs of all other outputs. So if you have more crude oil, it's cheaper to produce both gasoline and diesel and so on. Okay, so if you produce more gasoline, you know it's cheaper for you to also produce more diesel. If you dig more oil wells, it might be cheaper for you to produce more natural gas. Okay, but that's about it. I think we will discuss that then in more detail in the tutorial class. In particular, the question is, how does that look like empirically? And perhaps you remember we had many either state-owned or state-managed utilities in Europe, like Deutsche Bundespost, which provided both postal services and telephone services. And the point is, telephone services included not only what you have today, the wires and lines which connect you to the Hauptverteiler, so to the main distribution center, but they also included the Endgeräte, the devices for the consumers. Okay, you could only get telephones from Deutsche Bundespost at that time. And so the point was somehow this is all part of this big, large natural monopoly, and subadditivity is everywhere. Actually, there is no, or surprisingly little, empirical evidence that there is a huge cost subadditivity. Typically, these studies find that there is some economies of scale out to a certain level of output. So if you think in terms of our Stadtwerke, our municipal electricity and gas companies, there are some which are certainly too small. If you have only a few hundred households, your overhead costs are much too high. A former PhD student of mine did some study on that, looking into mergers, and he saw that in many instances you are below some minimum efficient scale in terms of the Stadtwerke, and that's why you see some mergers here. But if you have municipal gas and electricity companies which are at the level of, say, several 10 or even 100,000 households, you probably won't see many economies of scale then. Okay, a problem here is that there is a distinction between classical economies of scale and the economies of density we already discussed up there when we discussed railways, and it's also important in postal services and railways. I think I have to go back in postal services. The point is it should immediately be clear. It's cheaper if your mailman has to distribute the letters in a densely populated area and goes to multi-unit buildings where he has, say, 50 letter boxes just at one spot, and doesn't have to walk for another mile to go to the next household, but just has a distance of 10 centimeters to get to the next household. This should be clear that these are economies of density. So these are similar to economies of scale, but are, as I discussed above there, the point is that you increase the number on railways. The point is that you increase the number of delivery points, and this increases delivery density and lowers the marginal cost per delivery point. I think I describe that in much more detail in the notes. Okay, the point is, in the notes I also gave you an evaluation from an article by Fass and Waverman in the Handbook of Telecommunications Economics on econometric cost functions, And the point is here, even though we have some evidence, the evidence is not so clear-cut. Okay, it's not so easy to determine whether you really have this global subadditivity, where you have both in a respective or a relevant range, where you have economies of scale. That might be easier to determine. But what about the economies of scope? And what they state is that the econometric evidence survey has appeared not to influence regulators' decisions guarding permissible market structures. The problem is basically that these models always require a leap of faith. It's not so clear whether the results are really robust. Okay. In another dimension, we have this problem right now. How much do we trust these virologists and their models? Okay, there's also leap of faith, but here we rather make an error which is conservative in a sense that we go for the safer solution. Okay, here in public play, it's always a problem in these kinds of public policy proceedings. If it's about to change something, that you have to say, okay, the change wouldn't do something bad. Okay, now I think I come in a sense to a conclusion of this part here. I just need to show up, yes, a conclusion of this part here. So what we now discussed at long time was the technological and cost attributes that imply that a single firm can produce output at a lower cost than multiple firms. This was our definition of a natural monopoly. This was our definition of subadditivity. Okay. Now the point is that, and I stressed that many times, and that's why I put up this EoScope quotation once again, that you have this technical natural monopoly in a technical sense does not mean that you get automatically a market to evolve to a point there we get a monopoly, actual monopoly, and at the same time it's not clear that you really should have one, that from a normative point of view. Okay, and so because that's what we will discuss later on. Even though it would be cost efficient to have only one firm, it might be from a competition or social welfare and regulation perspective be better to have several firms in a market. Okay, in particular, given the asymmetry of information. So the point which is stated here is that many authors do include a definition, do include in their definition of a natural monopoly the answer to the behavioral question of what cost and demand attributes lead industries to evolve to a monopoly. Okay, we didn't discuss that here. Okay, and the point is here, we do not, given what we did, we do not get any conclusion that a single firm will naturally emerge in equilibrium, and is also not clear whether we should have one. And what we do in the next step is whether we don't address the normative question here, whether we should have one, but we address the positive question, whether these subadditive questions, subadditive cost, will lead to a market where we have only a single firm. Okay, and that depends on the competitive interactions between firms in the market and potential entrants. Okay, and that's actually what we are doing in the next chapter when we discuss contestable markets, where we look at a cost structure which is subadditive, and then look into how many firms will be active and what will be the performance of the market. That means how are costs above marginal or average cost, or how does that look like? Okay, and this, I want to stress this once again. So natural monopoly in a very beginning just, or in a very basic sense, means just that we define it technologically via subadditivity, and that is simply a cost concept. Okay. Nevertheless, many industries we look into, and in a general discussion, we always speak of natural monopolies. When we talk about the utilities, about electricity companies, and so on. And the reason why that is the case is what we turn to next, namely to sunk costs. Sunk costs do not appear in the definition of natural monopoly. Why I said excuse me, you see I should make a break here. But anyway, I move on till the end of this chapter. I think there are only left 2 or 3 slides. So the point is here, if we have sunk costs, you will see that it's quite possible that we get then a link between subadditivity and market structure, because there is an income. If there's a so-called incumbent, a firm in a market which already has incurred the sunk investment, it typically has an advantage compared to potential entrants. And so if we have subadditivity, we might get a behavior and performance which leads to a natural monopoly. We will discuss that in the end of the next chapter. So if that sunk costs lead to really an entrenched monopoly, we can really expect that it has an effect on market performance, and of course we might then get an unregulated monopoly. So I will get back to that importance of sunk costs many times later. Okay. Yeah, here just some definition from EoScope. We discussed that previously. So sunk costs are associated with investments made in long-lived physical or human assets whose value in alternative uses or different locations is lower than its intended use. At the extreme, an investment might be worthless in an alternative use, and in that sense, we have what is called irreversible cost. Just think of the Eurotunnel. What you have sunk there is lost if you no longer operate the Eurotunnel. Also exists in nuclear power plants. There are already sunk costs, even to dismantle them. These costs are already here. Okay, and the sunk costs are different from fixed costs. We discussed that previously. We cannot adjust the respective cost, the capital cost. Okay, if we have built some, or if we have built some factory with machines, we might use these machines in different kind of uses. Okay, so that's what's important. The sunk parts of an investment, in particular its relevant capital costs, are no longer relevant for the decisions to be made. Think of the Eurotunnel. Even though the Eurotunnel operating company makes losses each year, if we look into what they would have to pay for the credits or for the capital they used to build the tunnel, as long as they manage to cover at least their operating costs and to get even a margin on that, it makes sense to operate this Eurotunnel. That's why we had several times a haircut, meaning that creditors just accepted some kind of reductions in the payments made to them. Why is sunk cost so interesting to us? Yeah, because most of the industries that have been regulated based on natural monopoly arguments, so railroads, think of the tracks. Okay, the most important part is not the steel you put in there, but the construction cost you have. Electric power, similar. The power plants, they don't have much of an alternative use. The telephone is in particular the wires you have put into the ground. That's a problem with getting fiber optical broadband interconnections for everyone, because 80% of the cost are just the construction costs if you have to lay that cable into the ground. Gas pipeline networks, of course, they are fixed. Water networks also. Cable television is the same. The point of all of these industries is that a large fraction of their total costs are really sunk. They are sunk capital costs. And therefore, these sunk costs matter so much. So it's important to us how sunk costs impact such an industry. Okay, now after this tour de force through the cost concepts, I want to make another short break here. Okay, I move on with the next chapter, contestable markets, and I don't know whether we will be able to cover that today, the war of attrition, but this is also part of this chapter. Okay, so after having discussed subadditivity at some times and the question whether, okay, put it differently, subadditivity means that it's from a technical point of view optimal to have a single firm produce the whole industry output. Now the question is, if we assume a certain market structure, namely contestable market, will we obtain this result, and what are the efficiency or welfare properties of this result? All this discussion of contestable markets goes back to a series of important papers by William Baumol, Panzer, and Willig, and which ended in a book, The Theory of Contestable Markets, published in 1982. And I want to show you what they did here in the next, say, 15 minutes. The point is here, the benchmark case is that we have subadditivity, actually, as you will see here in a very simple form, fixed cost plus constant marginal cost. So we have decreasing average cost over the whole range. And we assume that there are no sunk costs. These are just fixed costs. If you don't become active, or if you have been active in the past, you can exit from the industry without any costs left. And for simplicity, we look into the single product example, and we assume that we have n identical firms which all have this standard kind of cost function C is F plus C times Q. The important thing is we have one incumbent, one firm which is active in the market, and all of the other n-1 firms are what is called potential entrants. We have given some inverse market demand function, so some downward sloping demand function where the price is a function of the output. The F is fixed but not sunk. So and that is very specific. We will discuss that later on. So firms can enter or exit the market freely without facing the risk of losing any of these fixed costs up to the point in that the firm actually produces output Qi and incurs operating costs. This means that there is really hyper-free entry and exit into and out of this market, and a hit-and-run entry strategy is possible. This really sounds strange in a sense. So the point is, if you think that your local electricity company has too high an electricity price, including the price of the network, you just jump in, undercut it, and get the business. Okay, as you see immediately, it's hard to set up an electricity transmission network within seconds and enter the market, and then if the incumbent happens to decrease the price, you run again. What might look more interesting or more realistic is just, for instance, competition in airlines. So if you have one connection between, say Frankfurt and New York, and Lufthansa offers that at a high price, you might have a Condor plant there, and Condor says, oh, I just undercut Lufthansa, and all of the customers who have tickets which can be which are refundable and so on, they just go to me, and I make this flight and transport all the customers. And if Lufthansa turns out to reduce the price as well, I just leave again as Condor. Okay, so the point is, you have, and this sounds very speculative and rather theoretical, and that's a common criticism of this theory, but I will get back to that. But the point is, it makes or it really assumes that we do not have fixed commitment costs prior to actual production. So you don't have costs for your aircraft previously. And therefore, all costs are effectively variable from an entry-exit perspective. There is really no difference between firms that are in and that are out. But if you have that, you get a very interesting kind of result. Actually, what we have here is some kind of generalized Bertrand competition. Now, once you have fixed cost. And how does such an equilibrium look like, or what are the equilibrium requirements or conditions? An equilibrium requires a configuration which is both feasible and sustainable. What does feasibility mean? It means that a market clear and the incumbent makes non-negative profits. So that is at the price the firm sets, or the which is in the price in the market, demand, or you get a certain demand, okay? And the market's clear, that is, you get a demand for what you throw in the market, and market's clear. No one is forced to buy, and another point is whether everyone gets something at the ruling price, but at least the firm can sell everything it wants to sell at this price. And the other point, I will illustrate that in a minute in a diagram. And the other point is that the incumbent breaks even, that is, revenue is larger than cost. The sustainability criterion means that the potential entrants are not able to enter the market and make profits. That is, there exists no price where I could undercut the ruling price, PA, which is smaller than P, so that I could sell something for which I find demand at this. That's why I was so I had a hard time to explain that up there. Here the point is that at this price you don't find enough customer so that you can break even as an entrant. It's really better, I think, to explain it that by means of the diagram I used here. The one from Josco, it's actually totally the same diagram as the one I used on Tuesday in the assignment. If I manage, yeah. Oh, I have to show it once again to you. That's what I showed you on Tuesday in the assignment. This is this diagram where you also have the demand curve in red. Probably I should erase it, but then I just draw it again. Okay, here you have Q, here you have the demand curve, here you have P, of course, here you have the demand curve, here you have some marginal cost MC, and you have some average cost, which look like this here. Okay, and now the interesting thing, and I guess I should move back to my slide, which you see is the same here. The interesting thing here is what is equilibrium. Now you see that we have two conditions. What is not shown nicely here is, of course, we should have something like this here and something like this as well. So the AC curve goes up and somewhere intersects the demand curve. And of course, we could also put a marginal revenue curve here. And what is clear, this would be the monopoly price. Okay, this would be the monopoly price, PM. And now, why is that not an equilibrium if we have contestable markets? Now, clearly, because if Lufthansa sells at a monopoly price, Ryanair would just jump there, take all the passengers, slightly undercut here, slightly undercut Lufthansa, and then take all the business. Lufthansa, knowing that, would have to reduce the price. And how far do they have to reduce the price? Yeah, certainly not as in the Bertrand paradox to price equal marginal cost, because at a price equal marginal cost, which would be here, the firm would make losses. And the only sensible thing is, and this is really just going back, our feasibility condition, the only sensible solution is that price is equal here average cost, because then you just cover your cost. Could an entrant profitably enter here? No, because if they would undercut that, there's no possibility, okay, no output quantity. No output quantity. So if you produce like this, you have this average cost, this would be the price. If you produce even more like this, you would have losses. So price equal average cost would be feasible, because our incumbent does not make losses. At the same time, it would be sustainable because there could not be entry. The monopoly price, as we had it here, is not sustainable because it could be undercut. However, the important point is here, and that's what you will learn in the assignment, if you solve for price equal average cost, there is another solution which is not really depicted in Josco's diagram, which is up here, where you also have price equal average cost, because you have two intersections here of the average cost with the demand curve. And of course, that's not a solution either. Of course, this would be a solution where the incumbent breaks even and makes zero profits, but of course, an entrant would enter here and charge the monopoly price. So this is, again, not sustainable. Yeah, so that's already it. Okay, it's actually straightforward and very amazing. Josco states that these are remarkable results. And what is so remarkable about that? Even though we have a natural monopoly, even though we have decreasing average cost, we get a result which is second best. What does second best mean? Of course, it's not first best, because first best means price equal marginal cost. But in that, if you have price equal marginal cost, what is clear, and I can really clutter this here, you would make losses, and the government would have to pay subsidies of this size. So if you face a break-even constraint as a government, what you get in terms of the result under contestable markets is really second best. Okay, this is as close to efficient uniform per unit pricing as we can expect in a market with private firms that are subject to a break-even constraint and have cost functions characterized by economies of scale. That's the evaluation of Josco here. The point here is, and what's really the achievement by Bommel Panzer Willich, how many firms are active in the market? Only one. One firm is active in the market. You have realized all economies of scale. And why does this single firm being active in the market charge only the price equal average cost and not a higher price? Because potential competition. Okay, one firm is in a market. In English, in American, you would write it like this, the one. And potential competition. Potential competition is so important. Even though these firms are not active in the market, they force, by their threat of entry, potential competition and the threat of entry, okay, they force the incumbent to charge a price which is equal to average cost. And this is really amazing, okay? The question later on, of course, is how relevant that is, okay? But here you see, and that's an important point, that even though you observe only a single firm being active in the market, you have a result as good as it gets, okay, in terms of this market structure. You cannot, as long as no first best transfers are possible, it's the best thing you can do. And this is really remarkable, okay? Hopefully this is clear so far. Again, we will have in the assignment problem where you exactly just derive this equilibrium, where you derive the feasibility and the sustainability conditions, and where we will look into that. A small aside here, you also perhaps hopefully remember what we did on Tuesday with this problem. It was actually the same problem I just showed to you, where we have, I jump to one note again, where we discussed these, where we discussed this question with the K. So where we had these cost function and we had the Douglas production function, and the point was that here our Q, P, and actually AC, how AC looked like was really depending on whether it looks like a U-shaped or in the relevant range, or whether it was quite different, or should probably use where it was quite different, something like this here, always increasing. It just depended on the capital K we had. I just have to look up how did this, somewhere I have a Mathematica file. Here it is. Our cost function, this is not the cost function, our cost function was output Q squared over K, where K is the capital in plus K, okay, and this was the result of Q is equal to square root K times square root L. Yeah, and the point is, the only point I want to make is this K here, and this K determines how the average cost here, how these are different average cost curves. Actually, I could draw much nicer, but in Mathematica, as I showed you, but these are different average costs where the shape of the average cost curve really depends on this respective K here. So the one is K0 and the other is K1. And now here, that's why I wanted to show you that actually, by the way. On the previous slide, you saw that the average cost curves are downward sloping in the whole relevant range. Remember, we discussed on Tuesday sometime what the relevant range is. If demand function were going through here, we would also have a downward sloping average cost curve in the relevant range. Okay, but if demand lies further outside, as it is depicted here, and that's I erase it again, you might get, as you have a given level of capital, you might get that the average curve is increasing again. Okay, it's U-shaped, and here you see the marginal cost. Now the problem is here, you see by construction here, it's still better to have a single firm being active, producing this outcome here, rather than having say two firms. Actually, the problem with this slide, by this also I took from EoScope, is that it's just a sketch. It's not really true, so that you cannot show it. The point which should be made here is that a firm could enter here with this, say with this output. Actually, the optimal output would be the one where price is equal marginal cost. And if one firm enters with this output, at this average price, or say at a price which is slightly lower, in order to produce the whole, actually the efficient second best output, the other firm would have to produce, probably I need now another color. The other firm would just have to produce, a second firm would have to produce, or the incumbent would have to produce this output, and if it produces this output, its costs are much higher. Okay, so the total, so the cost of the one firm would be this here, and the costs, the average cost, so, and the other firm would be this here. And the problem is here with this diagram, I probably should produce one here with Mathematica where it's exact. The problem is, and that's what I state in the notes, that actually, if you have entry here, total costs increase. What does this mean here? Now, you have a market structure where you have subadditivity. Okay, you have subadditivity because it's cheaper from a social point of view to produce the whole industry output here. But if you have the potential of entry, or if you allow for entry, another firm might enter with a lower amount, which is still in the range where you have economies of scale, but not these economies you have right here. And if entry happens here in this case, it might lead to higher costs than without entry. Okay, you might get a worse result. That's a problem here. Ken Train describes it some detail in his book Optimal Regulation. So the problem is here, if you have such a structure, you would have potential entrants which want to enter. They want to enter, but you don't know whether it's a good thing to enter or not if you a regulator and wants to maximize social welfare. We will later on see anyway, because that we typically do not prohibit firms to enter, but as a regulator you might think about it. Okay, actually we didn't have entry in the far distance bus business, in the coaches business in Germany until a few years, if you might remember, or if you remember. Okay, yeah, hopefully this got clear. Perhaps we can discuss that in more detail, or once again in Tuesday if you want to, because here the problem is that the shape of the curve is not, you see, the C is 1 plus Q squared, and this is actually almost or very similar to what we had. Okay, I move on, even though this might have been not so clear as I hope, but anyway. Contestable markets in a multi-product world with subadditivity. So what we will discuss in the course, and what the problems and the assignments are about, will be pretty much this kind of standard case. Okay, this kind of standard case where you have given some inverse demand curve, D of Q if it works, and you have given some cost function which is F plus C times Q. That's what we typically have. Very straightforward. That's what you have to look into. Of course, from a more general point of view, it's interesting, as we introduced this economies of scope previously, how contestable markets work in a multi-product world, and what the result will be. Now the point is rather straightforward here. If it's really a global cost subadditivity, a single firm will take all of the advantages of cost subadditivity. This firm earns zero profits, and the revenues that firm earns from any subset of products is greater than or equal to the incremental cost of producing the subset of products. Okay, there is no cross-subsidization in a sense that the price is charged for any product or set of products that covers the incremental cost to produce them. So what does this mean? If you're Volkswagen, suppose there will be global subadditivity, or there would be global subadditivity in the production of cars, and you have several models. Now the point is here, you would charge for each model at least its incremental cost. If you were not choose the incremental cost for, say, the Charan, and apart from that you earn zero profit, that means you cross-subsidize the Charan. And if you cross-subsidize the Charan, that means some other cars, so the total amount of all other cars has to bear higher cost than the standalone cost to produce all of these other cars. So the Charan is sold at a price below its incremental cost, so the others pay more than their standalone cost. If the others pay more than their standalone cost, actually another firm could enter and produce at this and undercut the incumbent, could undercut Volkswagen and sell at the standalone cost. Okay, cross subsidization is not possible with contestable markets. And of course, nevertheless, you cannot sell every product at its marginal cost because you have subadditivity, so because you have common cost. And the point, or the theoretically interesting point, is that under certain conditions, the firms will charge the optimal second best linear price, which are the Ramsey-Bourdieu prices, which we will derive in, I think, chapter 6 or 7. Okay? Yeah. So given the zero profit constraint, Ramsey prices are the optimal prices. Oh, what I just noticed is that I run out of time, but that doesn't matter. I will stop here. I will discuss cross-subsidization next Thursday. The important point today was that we were able to introduce contestable markets, because that's what we are going to discuss in assignment 2. So now going back to assignment 2, you should be able to discuss all the questions we have here. Okay, I think, yeah, all the problem sets you'll find here, you will be able to discuss based on what we discussed or what I presented today. Okay, that's about it. I want to thank you for being with me. If there are any questions, I'm still available in WebEx right now, and I just want to say goodbye.